in. Okay, so question number 1 here. A political candidate has asked you to conduct a poll to determine what percentage of people support her. If the candidate only wants a 5% margin of error at a 95% confidence level, what size of sample is needed? Okay, what in the world are we talking about? Let me give you the big picture. I want this to make sense so you see why people do statistics so much in the real world, because it's very, very applicable. So, this is not one of those math classes where you say, I don't know what it's all for. With stats, it's really clear what we do. So let me make it clear. Basically, whenever you do a study, suppose you get this political candidate and she wants to know what percentage of the people support her, right? She wants to know, what do I have? Do I have 50%, 80%, 30%? What percent of the population agree with my ideas and are supportive of what I'm doing? So she needs to know that in order for how she conducts her campaign. So how do you figure that out? Or this could be a medical treatment. What percentage of the patients? Let's make it even more important than a political leader. How about some kind of special new drug to cure a certain kind of cancer, to treat a certain kind of cancer? What percentage of the patients are being helped by this new drug, right? So there's very important questions that we seek to answer with statistics. Statistics is very helpful to medical science, to politics, to business, to law, to the government, to many people. Statistics is helpful. Okay, so great. I got it. Yeah, all right. The political candidate or the doctor want to determine what percentage of the people support her or that the drug helps. So go do a study, right? Okay, but when they do the study, remember, there's no way to ask everybody. There's no way to ask everybody in the state, right? If this is a state senator, a congressperson, congresswoman, she doesn't have, you don't have the resources or the ability to ask everybody in the state. And the same way with the medical treatment, you can't find out every single person that's ever taken the new drug, if it's helped them. You can't do that. There's too many people, and they don't all answer, and you can't find them all, right? It's impossible. So what do? You cannot find everybody, right? So what you do, let me write that, you cannot find or ask everyone. So instead, you ask as many as you can. So, and the question becomes, how big of a sample do you need? How big of a sample do you need? Like, how many people do you need to ask? Do you realize, I'm sure you realize, that the more people you ask, the more believable the results are? You know what I mean? Like suppose there's a new, let's stick with the political. I keep wanting to go to the medical because I want something that's more important, but we'll stick with the political candidate. Suppose she asks 10 people and 6 support her. Suppose she randomly, let me put randomly in front of here. Suppose she randomly asks 10 people, right? Her people, her committee goes out and randomly asks 10 people on the street and 6 support her. So then she would determine that 60%, 6 divided by 10, which is 60%, as you know, 60% support her. 60% of the whole state. 60% of the whole state support her. Is that a believable study? That's not very believable, is it? That's only 10 people. I mean, that's not many people. You could have just got a lucky group of 10 people, right? That's just not a big enough sample size. If you only ask 10 people, you could have got all 10 that support you and think, yeah, I think 100%, 10 out of 10. I think 100% of the state, everybody in the state supports me. And that's just crazy, right? So you see the problem with doing too small of a sample? You're going to get crazy results. So you need to ask more people, don't you? You can't ask only 10 people. Well, how many people do you need to ask? I don't know. What if you ask 100 people? Is that enough? Or how about 1,000 people? Is that better? How about 10,000 people? Well, yeah. The more people you ask, the more believable, confident we are that we're getting at the truth, right? Again, we can't ask everybody. It's too big. The state is too big. It's impossible. But we want to ask as many as we can. And so the more we ask, the bigger the sample, the better. Now, how much better? Here's the real question. How exactly big do you need to go? And we know the more you ask, the more believable the results are, right? The more confident you are that you're getting at the real true percentage of the whole state that supports. You know, if you ask 10,000 people and it comes in that 61% of those 10,000 people support that political candidate, then that's pretty believable, isn't it? I mean, you asked a lot of people. So if 61% of those 10,000 you randomly asked support the candidate, probably that's pretty close to the true percentage of the whole state, isn't it? Are you tracking with me? Does that make sense? The bigger your sample, the more you believe the results are accurate, really reflecting the truth of the whole state. Okay, so let's get to business. How big do you need to go? I mean, exactly, precisely, rather than just this random talk of, well, more is better. Yeah, sure, more is better. But how much more? How big exactly do we need to go? How big of a sample is needed? Well, she's saying she wants only a 5% margin of error. You see, the more people you ask, the less chance of error. And she's saying she only wants a 5% chance of error. And she wants to be 95% sure she's got the real, 95% sure she's got the real percentage of the state that supports her with only a 5% chance of error. If that's what she wants, if she wants that kind of accuracy, the question is, what size of sample is needed to achieve that kind of accuracy? Well, where am I going to go to find that out? You know where I'm going to go, right down here to the exam 3 notes, right? And this is number 1. So I'm looking at the exam 3 notes. You all have the exam 3 notes out there on the Canvas course site right in the beginning of Unit 3, right? You all know what I mean, right? Maybe it'd be helpful if I showed that for just a second. Here we go. So you're seeing my screen? There it is, Unit 3, confidence intervals and hypothesis. Right, exam 3 notes. There it is, very top of the module. These are the modules, right? In our course shell. There it is, exam 3 notes. Just click right there. You've got the exam 3 notes right at the top of the Unit 3 module. Grab those for yourself. All right, let's go back to the problem. So you're going to want those formulas off the exam 3 notes. Okay, so here they are again. Here's the formulas. Here's how to find sample size. Findings like how big does your sample need to be to achieve the accuracy that you want? Well, Z equals, for the first thing you're going to do is go Z equals inverse norm right here. Inverse norm 1 minus confidence level divided by 2, comma 0, comma 1. So that's the first thing you're going to do. And then you've got to decide if it's a P percentage or a mean. We're going to do both of those in these problems. sample P unknown, sample P known. You use this formula or that one down here for the mean. You got to figure out which formula you need. All right, so let's start with this. For the in, here is Z. So we got to start with this thing right here, this Z thing. So let's do that. So coming back up here, we'll begin with that. So in fact, it might be helpful. Yeah, no, we're good. So I'm going to go Z equals inverse norm. Okay, and then there's going to be a parenthesis 1 minus confidence. Go down here, look at it. So it's 1 minus confidence divided by 2, comma 0, comma 1. So 1 minus confidence divided by 2, comma 0, comma 1. Does everybody see that? So, and you know where inverse norm is, right? It's in second. You got to hit second and the vars button, which has distribution above it because you're going to the distributions. So you hit second distribution, vars, which is distribution, and then you find inverse norm. Okay, and so we're going to put in there 1 minus, what's the confidence level? 95%. So 0.95 divided by 2. There we go. Inverse norm, parenthesis. In fact, let me make the parentheses a different color so that it'll be super clear for y'all. Let me do that. Okay.
What if mine says 99.5? Do I put 0.995?
Exactly. Exactly. Yep. If yours is 99.5. So yeah, you just always move the decimal back 2 places, right? When you go to a decimal, from a percentage to a decimal, that would go to 0.995. Exactly. So whatever percentage they give you, just move the decimal back 2 places, and then put 1 minus it divided by 2, comma 0, comma 1. That's your Z.
Where are we putting the
I'm sorry, what was that question?
minus 0.95? Where are we putting the stuff you have in parentheses at?
Into the inverse norm. Now there's 2 kinds of, there's a newer and an older TI 8384 calculator. So I have the older kind. So the older kind, you got to put it all in parentheses, just exactly like I'm writing on the screen there. For the newer kind, let me show.
Yes. No.
For the newer kind, let me share my emulator. There it is. That over here. Okay. I'll hit second. Var, go down to inverse norm. And let me move this over here. This over here. All right. Good. And then go down to inverse norm and hit enter. I'm on inverse. Now, for this is the newer kind now. So for the newer kind that does not have the parentheses like this, then you have to do it. The area is going to be the parenthesis 1 minus 0.95 or whatever your percentage is. So if you had 99.5, then this would be 1 minus 0.995, right? Parenthesis divided by 2. Everybody see that? Let me back up. Let me clear mine. So again, parenthesis 1 minus 0.95 for mine, or whatever your percentage was, divided by 2. Everybody seeing that? 1 minus 0.9. You got to put parentheses. You got to put you can't leave off those parentheses. They're absolutely essential. You've got to put parentheses around the 1 minus 0.95 or whatever percentage they're giving you on the problem, changed to a decimal. 1 minus it in parentheses divided by 2. And then see how the mu and the sigma are 0 and 1. They're already good. You don't need to mess with those. You can just go on down to the paste and hit enter a couple of times, and you'll get your answer. Enter.
So the 1 and the 2 never changes. It always just stays 1 minus point whatever divided by 2.
Correct. It always does. It never changes.
And then so just like that, then the mu and the sigma are always going to be 0 and 1.
Right, exactly. All of that stuff is set in stone. The only thing that changes is the percentage. That's right. Exactly. So then you
gives you a negative, would the answer be a negative?
Yep, it comes out negative. Correct. The answer
I
should.
don't understand what I'm doing wrong.
Okay, so we're glad to help with individual things in the breakout time. Right now, I can only address what I'm doing, and questions if what.
Yeah, can you show me like how you did it?
Yeah, it's right there on the screen. It's exactly what I did right there. Parenthesis 1 minus 0.95 with parentheses around it.
So is it always going to be 1?
Yep.
Okay.
It's always going to be 1. And you put in your percentage right here and you divide by 2. I'm on inverse norm, which we get by second vars. Everybody seeing that? And so let me go back.
So just to confirm, it's okay to get a negative number.
It should be, it will be a negative answer. Correct. It's a negative answer. Negative 1 point something or other. Correct. Negative answer. This is just the beginning. We're not done. We have more steps to go. This is just the first step. It's not the final answer. The final answer will not be negative. It's just the first step. And it is negative. Correct. All right, let me go back to my iPad. So if you have the older kind of TI like mine, then it's just all sideways like this in parentheses. If you have the newer kind, well, you saw that a second ago on the screen, right? The newer kind, I guess I could write, I just don't want to use up all of our space here. So, yeah, maybe I will. Let me just erase this and I'll just bring it down so we have room for all this. All right. Yeah. Okay, so there we go. Question 1. Okay, yeah, so here it is in its own paper. Yeah, so again, the Z is inverse norm, parenthesis, and then parenthesis 1 minus confidence level divided by 2, comma 0, comma 1, or if you have the newer kind, then it's area mu sigma, and it's the same thing. 1 minus confidence level divided by 2, 0, 1. Right? And you know where inverse norm is? That second vars, which has distributions above it. There we go. So there's the beginning. So then we get our Z. So that is the Z, and it Z equals, for me, so the one I just did, let me go down, it's going to be a negative number. And I'm getting negative 1.959963986 to give you all my digits. So for mine, this was 0.95. 0.95. Okay, so far so good. So we got a negative Z number. That's just our first step. Now we've got to come on down. So that's the first step. It says get your Z number. We're going to do that for every one of these problems, so you'll get more and more comfortable with it. Get your Z number. We got it. Now go into decide which of these three formulas we're going to use. How do you know? Well, is it a P percentage or a mean problem? Let's go up and see. Does it say mean anywhere, or does it give us a percentage?
It gives us a percentage.
Yeah, what percentage? Right there, huh? There it is, exactly. Does everybody see that? It's a P. It's not a mean problem. It's a nice problem. It's not a mean. It's not an average problem. It's a what percentage? It's a P, not a mean. Okay. So we come to, so we're talking about a P, not a mean. But P has two different formulas, whether the sample P is unknown or known. What does that mean? Well, if they don't say anything, it's unknown. Let me just write that for you. P, unknown P. Why? Because they never said. You'll see in a minute on some of the other problems. They never said something like, we think P is 0.3 or something. You know, they never said anything about what they think P is, the percentage of people who really support the political candidate. Sometimes they can guess ahead of time. We think about 30%, 0.3 of the population support the candidate. They didn't say anything like this on this problem. They will on some of the other problems, and I'll point it out to you at that time. But for now, this one, the P is unknown. They never said anything about what they think or know about the P value. It's completely unknown. So we come down here and go, oh, okay. So we're talking about P, unknown. There's my formula. N equals Z squared, 0.25 over E squared. Let's write that down. So there is our formula that we're going to have to crank. N is Z squared, 0.25 over E squared. So there it is. There's our formula. N is the sample size. That's what we're trying to figure out, right? How big does the sample need to be to get the kind of accuracy that this political candidate wants? She wants to know within a 5% margin of error, 95% sure what the real percentage of the state who supports her is. So how big of a sample does she need? How many people does she need to ask at random in order to get that kind of accuracy? So the more the better, right? The more people you ask, the more accurate your results are. The more trustworthy they are, the less error possibility involved in your study. All right, so there's our formula. What in the world is Z? Z is this thing we just calculated, right? That's that thing you just calculated. So here's the best way. So now watch this. I'm going to try to really help you here. So what you want to do to make this as easy as possible, this is not easy, is you want to hit second, the answer button, the one that's above the negative at the very bottom of the keyboard. So step number one is you get the Z, which we just did. Step number two is you're going to go right here. So step number one was you do the inverse norm and you get your Z. Step number two is you hit second answer. That's the answer you have on your screen right now. Right? That'll pull up that Z value and you go to the 2 power. So you just did Z squared to the power of 2. And now you got to multiply by 0.25. That depends on how new your calculator is. Sorry, but there's a couple options. You might need to do a right arrow. You may need to do right arrow to return to the main, to get out of the power zone. Let's put it that way. To get out, I should say. Out of the power zone. Maybe not. It depends how new your TI calculator is. The newer ones put you up in the power zone, which is actually very nice, but then you need to get out of it with a right arrow. You may need that, you may not. And then you want to go times 0.25 and then divided by air. What's the air? It's right here, right? 5% air. So you don't need parentheses. 0.05 to the second power. Enter. There we go. That's what you need to do. That's not easy. You got to follow all those steps, and it takes practice. Once you get the hang of it, you'll be good at it. So give that a try.
Can you do that again?
It's right on the screen. So follow the steps right on the screen. I'm getting the answer 384.1. And here's the last trick. Notice what it says here. Round answer up. All of these say that. Round answer up. Round answer up. In other words, why do we round it up? So that means even the 0.1 rounds up to 385. Even though 384.1 rounds closer to 384, we always round our answers up. So I round up to 385. Why? Because to get the exact accuracy that she wants, she needs to talk to 384.1 people. Remember, these are people. This is the sample size. These are people. How do you talk to 384.1 people? How do you talk to 0.1 of a person, 1/10 of a person? You only talk to them for a second. You only talk to them while they do 9 other things. You have 1/10 of their attention. I mean, that's just silly, right? So instead, that means you need to talk to one more person, 385 people. And improve your accuracy.
Mr. Hearn, I have a question.
Question?
So my margin of error is 0.5%. So when I put it in my calculator, it's supposed to be 0.005, correct?
Well done. Correct. Yeah. If you had let me write that. That's a good point. If you had a 0.5% error, that would be 0.005. Right. You guys know whenever we change from percentage to decimal, we always move the decimal back 2 places. Correct. So if it's
And then also
back at the end, you're going to need to go back 2 more.
Also, I have a question because the homework is asking for to round it to the 4 decimal places. So we don't give it a whole number then, correct?
No. Read that carefully. That's not what it's saying. It's
the Z value.
Final answer. It's saying
Okay.
round the earlier. It's a good question. It's saying round the earlier part to 4.
That's why I was getting messed up. Okay. Thank you.
Yeah, good question, right? Yeah,
What is the
rounding, but it's not talking about the final answer. It's talking about the intermittent result, the Z. It's talking about the Z. It's talking about the first answer you get for the Z to make sure you use at least 4 decimal places on that. I think it's better to do it exactly like we did it. We're using the whole Z. So just ignore that part of it and just do exactly what I've got here. You'll be good. Final answer is a whole number. It's people. We don't want to round. 85 people for mine anyway. Does that make
What is the E squared?
What was that?
What is the e squared? That's what, like, I'm confused on that. It says z squared times 0.25 over e squared.
Right, over e squared. So that's what I did right there. So the E is the air, margin of error. So they'll tell you in the words of the problem, the percentage margin of error. That's the E, the air. And then you just move the decimal back 2 places. So they gave me 5%. I moved the decimal back to be 0.05. Some other people got 0.5%. So they moved the decimal back to get 0.005. And then you go to the second power and enter, just like that.